Today we are going to discuss about the chapter Atom and Molecules given in the science book of class 9th. Indian and Greek philosophers were very eager to know about the matter. They were given some ideas about the matter. The first Indian philosopher, Maharishi Kanad, told that if we go on dividing the matter, ultimately we will get the smallest particle which further cannot be divisible, and he named these particles Parmanu. Another Indian philosopher, Pakuda Katyayama, elaborated the philosophical idea of Maharishi Kanad and told that these particles normally exist in combined form and ultimately we will get again the form of matter. Around the same era, ancient Greek philosopher Democritus and Leucippus also suggested ideas about the matter. He also given the statement that if we go on dividing the matter, there will be a stage when particles obtained cannot be further divided, and Democritus called these indivisible particles atoms, which means indivisible. By the end of 11th century, scientists recognized the difference between element and compound. Scientists are very keen to find how and why element combined to form a compound, and what happened when element combined to form a compound. The first one, Antony L. Lavoisier, laid the foundation of chemical science by giving two important laws of chemical combination. The first law of chemical combination is known as law of conservation of mass. According to Antony L. Lavoisier, during the chemical reaction, there is no change in the mass of the element. It means the mass of element can neither be created nor be destroyed in a chemical reaction. Lavoisier, along with his friend L. Proust, Joseph L. Proust, noted that many compounds were composed of two or more elements, and each such compound had the same element in the same proportional, irrespective of where the compound came from or who prepared it. Laplace given. Second law of chemical combination called law of constant proportional. According to law of constant proportional, in a chemical substance, the elements are always present in definite proportional by the mass. For example, in water, the ratio of the mass of hydrogen and oxygen is always 1:8, whatever the source of the water. We get the another example. In ammonia, the ratio of nitrogen and hydrogen always in 14:3 by the mass, whatever the method or the source of the formation. We get the carbon dioxide either by burning the carbon in the presence of oxygen or by heating calcium carbonate, but the ratio of the mass of carbon and oxygen remains same, that is 3:4. The third law is given by Dalton's, and this law is called law of multiple proportion. According to law of multiple proportion, when two elements combine together to form more than one compound, then the mass of first element and the number of molecules or atom of first element remain constant, and the ratio of the mass of the second element present always in simple ratio. For example, in water there is 2 molecules of hydrogen and 1 molecules of oxygen, but in hydrogen peroxide there is 2 molecules of hydrogen and 2 molecules of oxygen, in which hydrogen is always 1 gram either combined with 8 gram in water or 16 gram of oxygen in hydrogen peroxide, and hence the ratio of the oxygen with the same mass 1 gram of hydrogen, the ratio remain constant, that is 8:16 or 1:2, and 1:2 is a simple ratio. In 1803, John Dolton, a British school teacher, composed a model of an atom known as Dalton's atomic theory, and he described the structure of matter, in which he combined all the theories given by the scientist. The main postulates of Dalton atomic theory are: first, all the matter is made up of very tiny particles called atom. The second is, atoms are individual particles which cannot be created or destroyed during the chemical reaction. The third postulate of Dalton atomic theory is atoms of a given element are similar or same in the mass and chemical properties. The fourth postulate of Dalton atomic theory is atoms of different element have different masses and chemical properties. The fifth postulate given by Dalton's in atomic theory is atoms combine in the ratio of small whole numbers to form a compound. The last postulates given by Dalton's atomic theory is the relative number and the kinds of atoms are constant in a given compound, and thus he included all the concept of the constant proportional, law of conservation of mass, and law of chemical combination. Thank you for watching the videos.